So we're going to be working through Struct, which is short for structures. This is going to be quite a bit more involved, so I'll try to break it up. I'm going to dive right into my screen, and I've got a little bit of code already written. You can see we've included input and output, so we want to work with that. I guess we'll have a reminder working with stdlib.h as well, and then our program should return exit success. Now at the very top, above our main function, we can declare a new type. So I should be a bit more specific. We're declaring a struct, and inside of that struct, we can have a few more different data types listed. So it's similar to the concept of an array, but you can have different data types. So for example, we could have integer ID, and then maybe we'll have an array of char even for a name. And let's say we only want names to have at most 30 characters in them. All right, if we set it up so that we're declaring an array like this with a constant number of elements, then when we go to use this struct, which we're calling record, then we can actually create variables of this struct type. So you can kind of think about structs similar if you're familiar with classes, except that everything you're declaring inside the struct is automatically public. So C programming language is not object-oriented, and you're not declaring whether things are public or private. So when we're declaring structs like this, you have access to the nested types inside of it. So the ID and the name, we go to declare a variable of this type, so struct record, and then we want to give the name of a variable. Let's start with first record. And we haven't initialized it, that's only declaring the variable. But we have access to the elements inside of it. So an ID and a name. So when we declare it like this, it's allocating memory locally on the stack. So this is different from doing the memory allocation we just did, where we were dynamically asking for memory with the malloc function. And that memory we had access to everywhere in our program after we get it. Whereas when we declare our variable first record right here, it's only available inside our main function. And it would only be available inside whatever the function is in that, only that scope. But one of the advantages of doing this is that I don't have to call malloc to create the memory space to have an ID for this variable. So because it's local, the memory is on the stack, it's set up for me automatically by the compiler. Then when we run our program and the function executes, this is when the memory is allocated, when the function executes. Okay, so for the ID, I could give it some number like lucky7, and then maybe for the name, we would have access to the elements, and we could individually set the characters. So it's kind of awkward to start with. And I might want to do R could do in Nano, if you look down at the bottom here, you've got cut text and uncut text. So what we could do, just to demonstrate one line at a time, I could do Control K, and that takes out the whole line. So how you get it back, you do Control U. But then you can paste that line again, and I can keep doing Control U a couple times. So I'm only going to do 4 characters for now, because I don't want bad habits where you're always doing a big chunk or a big block of individually assigning each of the characters. There's better ways of working with strings than this. So after this, we will be moving on and thinking about those better ways of strings later. The last thing I would need to do is one more Control U, and then instead of an actual character, I have to finish off at the end of my string \0, so the null character. So if I want to print it as this array of characters, if I want to print it as a string, any of the other functions that I could work with, like printf, they're going to be expecting that the end of the string has the null character so that it knows where the end of that array of characters is. And that way it will automatically display for us a whole string. So keep in mind that when you're working with strings in C, they have a special name and they call them C strings. And that what you're really working with are array of chars like this. Okay, so we could do printf. We'll print our ID for our first record. And we'll do %d like we've done, and then \n to end the line for that. And we can grab it by referring to it the same way we assigned. So first record.id to get access with the dot operator or the member access operator. And then I'm going to have to remind myself what the format specifier is for strings when we do printf. So if we do first record.name, and I'm looking back at my lines and I know I have to move on to each of the next characters that we've got. And I'm not concerned with assigning any of the values for the remaining 30 characters, the rest of the 30 for now. If I remember correctly, I think it would be %c. It might just be one character. We'll give that a try first. We give it the pointer, which is the name of the array. So remember, again, that's a pointer we're giving to printf. So it's going to use that as the beginning to, and a memory address to the first character in the array, and then print all of the characters that it can all the way up to, but not including \0, so the end of the string. So that's what we're looking to do. Go ahead and compile and see if we have any errors and deal with them. And give it a run. And it's only giving me the one character. So it looks like it's interpreting the memory address for name instead of, and trying to interpret that as a character. So it's using the value of the memory address and trying to interpret as character. Let's go back in and let's give %s a try. And I'm assuming that's for string. That would be my best guess before I have to look something up. And there we go. We've got my first name shortened. So with printf, what you want to give it when you're trying to format for strings is you're giving it a C string array, or sorry, just a C string, which is a char array. Anytime you're trying to create a string like that, just always remember you're going to have enough elements inside the char array for that last null character \0. Now we've been working with one struct variable, and we could have more than one. And I really wouldn't want to work with chars this way. Really what I would want to do is a different kind of allocation when you're working with structs, especially if you're trying to do allocation for a string. So wherever you can, you want to try to set it up to work with string literals so that we can use double quotes and just pass in the values of what we would like. So I'm going to give that a try. And I'm going to do Control K, K, K to get rid of all of that. Yeah, and I'm going to get rid of this ID equal to 7 as well. If we want to do an implicit initialization, we can. And like before, instead of listing integers, so we would have 7 for the first element, because this is the first nested structure or primitive data type that's inside my structure. And I can give a value for that, for the first element inside my struct. And then for the second element, you might be wondering, okay, how am I going to set up the string? And this is where we try to set it to a literal like this. The compiler will place \0 automatically for the end of string literals like this, which is a nice advantage for initializing things this way. Excuse me. So I'm expecting that to work. I might have some errors if I've forgotten something. And we get the exact same functionality again when we go to compile and then run. So a much nicer way to initialize, so it's good to be aware of these different ways. If I would go back in and try to play around with it some more, you don't have to initialize everything. So you might be wondering, how would I get away with only initializing part of it? If we give it the reference to the array, I'm hoping we could just assign it like that. And I'm going to give that a try. And then the ID is probably going to automatically be set up with 0 when we've got local initialization like this. Maybe I'm wrong about that, but we're going to see with the output for this now that we've added it. I'm just going to double check my program. So I'm going to do cat. And we've got the edits that I have. And I'll do clear. We'll go back up to compile. It's saying I've got an error. The name is undeclared, first use in this function. Rename. So I'm going to pause and remind myself what I'm missing here for doing the assignment. Oh, I think I might remember. So I'll really quickly, I'm going to go back in and double check if I can remember what it is. Square brackets 1. I might be wrong about that. So this is my very last desperate attempt to try to remember how to assign things if we don't want to assign everything with an implicit list like this. It says array index in non-array initializer. Okay, so I'm going to have to go in and remind myself how to do that. Okay, so I had to go back to the documentation. When I take a look at implicit initialization, you've got the members inside of the struct. You can initialize them inside your list like this with the dot before the name. So that's the only part of it that was missing. So if I go back in, get rid of that square bracket and do dot name. Maybe there might be a warning. Okay. And then we have first record.id equal to 0. Now you got to watch out. If you don't initialize things at all, it's probably going to be junk inside when you go to try to refer to the elements and try to print what values are stored there. But because we used an implicit initialization list, any of the other members inside of the struct, like our ID member that we did not set a value for, they will be set to a default value. So it's typically either 0 or null if it's like some kind of pointer inside your structure. And depending on the data type for the members inside, there's some kind of concept of 0 depending on the type. So let's look at an experiment at what happens if you go in and we don't actually initialize anything and we just declare a struct variable. What will be printed? There you go. You get a bunch of garbage from memory that's just pulled out when you try to declare your variable, but you haven't initialized anything. So you got to keep that in mind if you're going to set things up for your program and you start declaring variables, but you haven't initialized. For local variables like this, it's going to be full of garbage from memory. So you could, that's actually really useful. If you go in and then instead of actually giving any values at all, you can say set equal to, and then just a set of empty braces like this. Then you're not initializing values for any of the members. And because this is an implicit initialization list that's empty, it will set all the default values for the member. So now when I go to compile and run this, you get an empty string for the name, and you get the ID to be 0. So I'm assuming for the array, it's actually being set to some kind of empty string. It's got no characters inside of it, rather than like a null pointer, because it is an array that's declared inside the structure type. Whereas if we declared a pointer and we were going to manage our own memory and allocate characters for a string dynamically, it'd be a very different kind of struct. And I'll probably do a video on something that looks like that next, together with maybe one more video in addition to this one, showing nested structures and started to do a little bit more struct. I should show type define as well. So there's quite a bit going on with struct. You can do things like arrays of structures that you could play around with, start to practice with something like that. Maybe try to puzzle out how you would do that if you haven't done it before. And then we've already done structures that have arrays inside of them. So you can pull together lots of different data types. If it makes more sense to organize your data that you're working with in your program, it's really nice to have struct, especially when we start getting into further concepts in operating systems where you very often need to pass a struct or a pointer to a struct so that you're not copying a bunch of data when you go into another function to work with it in a different scope. You don't want to be copying a bunch of data that way. Instead, you would pass a pointer to a struct. And you have to be comfortable with that, because a lot of the functions when you're working with operating systems, they're expecting some kind of pointer to a struct so that you can control what's going on. We're going to be doing a lot of that later.